Good morning, students. First, we take overview of last lecture. Importance of communication. So, what is the communication? It is the exchange of information from one place to the another place, or convey of information from one place to the another place. Okay, there are different types of communications: verbal, non-verbal, via facial expression. By using written words are the types of your communication. There are two main barriers of the communications are distance and language. Out of them, the distance problem, which is solved by using the long distance communication. Okay, next we see in the types of signal. There are three types of signal: analog signal, digital signal, baseband signal. Analog signal whose amplitude which it changes at the every instant of time. Then this signal which is called as an analog signal. These analog signals are continuous in nature. Next one, it is the digital signal. The digital signals are continuous in nature, whose amplitude which is does not changes at the every instant of time. For some period of time, it remains constant, which is denoted by 1 and 0. Okay. Next one, it is the baseband signal. Baseband signals are electrical equivalent of your original information signal. It is called as a baseband signal. These baseband signals are low frequency signal, and low frequency signal cannot travel for long distance. Next one, it is the block diagram of communication. So in that block diagram, the blocks are input signal. Next one, input transducer, transmitter, communication channel, receiver, output transducer. Okay, when your signal which is travels from transmitter to receiver, the noise which is get added into it. Okay, the input signal, which is also called as a message signal, input signal which is given to the input transducer. Function of input transducer, it converts the input signal into the electrical equivalent of signal. Example of input transducer are microphone and TV camera. Then electrical equivalent of signal which is given to the transmitter. Function of transmitters are transmit the signal, increases power level of the signal, and convert the signal into the suitable form for the transmission. It consists of electronic circuits such as mixer, oscillator, power amplifier. Then it is given to the communication channel which is either wired or wireless. For the wired we are using the wires and cable, and for wireless we are using the air. Okay, then when your signal which is travels from transmitter to receiver, the noise which is get added into it, noise which is unwanted electrical signal which is get added into the signal. When your signal which is travels from transmitter to receiver, the noise having of two types: natural noise, man-made noise. Natural noise are lightning, radiation from sun and star, and man-made noise are noise from automobiles, welding machines and motor. Then the function of receiver, it receives the signal and it converts suitable form of the signal into the electrical equivalent of signal. It also consists of electronic circuits such as mixer, oscillator, power amplifiers and detector. Then the electrical equivalent of signal which is given to the output transducer. Function of output transducer which is converts electrical equivalent of signal into the original information. Example of output transducers are CRT and loudspeaker are the example of the output transducer. This one is a block diagram of communication. These points are seen in the last lecture. Today we start with electromagnetic spectrum. So first we see what is the electromagnetic wave. Okay, when we are considering the wireless communication, at that time your transmitted signal which is in the form of electromagnetic wave, this electromagnetic wave which is consist of electric field and magnetic field, and these electric field and magnetic fields are perpendicular to the each other. Electric field generated due to the voltage, magnetic field generated due to the current. These electromagnetic waves can travel with velocity of light, and velocity of light is 3 into 10 raised to 8 meter per second. Okay, These electromagnetic waves are also called as RF waves. What is the RF? RF, it is the radio frequency waves. It is the radio frequency waves. And these electromagnetic waves can travel for the long distance. So, figure which is shows the electromagnetic spectrum. This electromagnetic spectrum means it is the entire range of frequency or wavelength. Electromagnetic spectrum means it is the entire range of frequency or wavelength. The frequency range which is divided into number of bands, and these bands are used for different applications of communication. This frequency range which is divided into the number of bands, and these bands are used for the different applications of communications. Okay, this frequency is divided into the separate frequency band, and each band which is having different name. Okay, this entire spectrum having lowest to highest frequency and longest to shortest wavelength. This entire spectrum having lowest to highest frequency and longest to shortest wavelength. Okay, then this electromagnetic spectrum which is divided into 7 categories depending on the nature of the wave. First one, radio wave. These radio waves are used for radio communication. Next one, it is the microwave. It is used for the microwave oven, aircraft communication. Next one, it is the infrared, which is used for TV remote control. Next one, it is the visible light. It is used for fiber optic communication. Next one, it is the ultraviolet rays are used for the photography. Next one, it is the X-rays. These X-rays are used in medical equipments. Next one, it is the gamma rays. These gamma rays are used for the PET scan. Okay. So next one, we see different bands, its frequency range, wavelength and applications. Okay. First one, it is the ELF. So what is the ELF? It is the extremely low frequency. Its frequency range is 30 Hz to 300 Hz, and wavelength is 10 raised to 7 meter to 10 raised to 6 meter, and it is used for power transmission. Next one, it is the VF. VF, it is the voice frequency. Its frequency range is 300 Hz to 3 kHz. Its wavelength is 10 raised to 6 meter to 10 raised to 5 meter. It is used for voice and audio transmission, which is used in telephone. Next one, it is the VLF. VLF, it is the very low frequency. Its frequency range is 3 kHz to 30 kHz. Wavelength is 10 raised to 5 to 10 raised to 4. It is used in submarine, military and navy application. Next one, it is the LF. LF, it is the low frequency. Its frequency range is 30 kHz to 300 kHz. Its wavelength is 10 raised to 4 meter to 10 raised to 3 meter. It is used in marine and navigations. Next one, it is the MF. MF, it is the medium frequency. Its frequency range is 300 kHz to 3 MHz. Its wavelength is 10 raised to 3 meter to 10 raised to 2 meter, and its applications are AM radio broadcasting. Next one, it is the HF. So HF, it is the high frequency. Its frequency range is 10 raised to 2 meter to 10 raised to 1 meter. It is used in AM radio broadcasting. Next one, it is the VHF. So VHF, it is the very high frequency. its frequency range is 30 megahertz to 300 megahertz. Its wavelength is 10 raised to 1 meter to 1 meter. And applications are TV and FM radio broadcasting. Next one, it is the UHF. UHF, it is the ultra high frequency. UHF is the ultra high frequency. Its frequency range is 300 megahertz to 3 gigahertz. Its wavelength is 1 meter to 10 raised to minus 1 meter, and it is used in mobile phone. Next one, it is the SHF. This SHF, it is the super high frequency. Its frequency range is 3 gigahertz to 30 gigahertz. Its wavelength is 10 raised to minus 1 meter to 10 raised to minus 2 meter. It is used in satellite and radar. Next one, it is the EHF. EHF, it is the extremely high frequency. Its frequency range is 30 gigahertz to 300 gigahertz. Its wavelength is 10 raised to minus 2 to 10 raised to minus 3, and it is used in satellite and radar. Next one, it is the infrared. This infrared having the frequency range of 30 to 430 terahertz. Wavelength is 10 raised to minus 6 to 0.7 into 10 raised to minus 6. It is used in remote control air conditioner room heater. Next one, it is the visible light. So frequency range of visible light is 375 to 750 terahertz. Wavelength is 0.4 into 10 raised to minus 6 to 0.8 into 10 raised to minus 6, and it is used in fiber optic communication. So these are the different frequency ranges, its wavelength and application. Next we see the transmission mode. Next point, it is the transmission mode. This transmission mode, which is divided into mainly two types, simplex and duplexer. Okay, this duplex, which is divided into two types, half duplex and full duplexer. It is divided into half duplex and full duplexer. This transmission mode defines the direction of flow of signal between two connected devices. Transmission mode defines the direction of flow of signal between two connected devices. Okay, first we see the simplex. Okay, this simplex, it is the one-way communication. Simplex is the one-way communication. So it is consist of transmitter and receiver. This transmitter only transmit the signal. Okay, this transmitter cannot receive any signal from receiver. So it is one-way communication. Only transmit the signal. Example of simplex are TV broadcasting and FM broadcasting are the example of your simplexer. So what is the simplexer? This simplexer, it is the one-way communication. It is consist of transmitter, receiver. Okay. In this transmitter only transmit the signal from receiver. No signal which is received by this transmitter. Okay. Example of this simplex are TV broadcasting and FM broadcasting, and communication between the keyboard and monitor. It is also example of simplexer. Next, duplexer. So what is the duplex? Duplex, it is the two-way communication. Okay, in this duplex, which is divided into again two types, half duplex and full duplexer. This half duplex, it is the two-way communication, but not simultaneously data transfer which is takes place. Half duplex, this half duplex, which is two-way communication, but not simultaneously. So again, figure of half duplex which is shown. So it consists of transmitter and receiver. So it is either transmit the signal or either receives the signal. It is two-way but not simultaneously. Example of half duplex is the walkie-talkie. Okay, in walkie-talkie either you can talk or hear. In walkie-talkie you are either talk or hear. Okay, this walkie-talkie having the push to talk button which can be used to turn on transmitter but turns off the receiver. When you push button, then you are talking and your partner can hear you, but you cannot hear what partner is saying. So this is the working of walkie-talkie. In this walkie-talkie, you are either talk or hear. You are either talk or hear. So it is two-way, but it is not simultaneously. So next one, it is the full duplex. So full duplex, it is the two-way communication and simultaneously data transfer which is takes place. It is the two-way and simultaneously data transfer which is takes place. The figure which is shown in full duplex figure which is shown. Okay, this example of full duplex are mobile and telephone. In this full duplex, transmitter and there is a receiver and simultaneously data transfer which is takes place. So in telephone and mobile, simultaneously we are talking and hearing. So this is the full duplex. Next we see comparison of simplex and duplex. And duplex which is divided into two, half and full. Okay, first we see definition. So what is the simplex? It is the one-way communication. What is the half duplex? It is the two-way but not simultaneously. And what is the full duplex? It is the two-way and simultaneously. Okay, examples are radio and TV broadcasting. Half duplex, it is the walkie-talkie, and full duplex, it is the mobile phone. And last one, it is the diagram. So diagram for simplex, this first one it is the diagram for simplex, second one it is the diagram for half duplex, and third one it is the diagram for full duplex. So this one is a very important comparison. So next one it is the data transmission. So next one it is the data transmission. So what is the data transmission? This data transmission means the movement of data which is in the form of bits between two or more digital devices. What is the data transmission? Data transmission means the movement of data which is in the form of bits between two or more digital devices is called as data transmission. Okay, this data transmission which is divided into two types. First one it is the parallel transmission and second one it is the serial transmission. Okay, this serial transmission which is again divided into two types, synchronous and asynchronous, which is divided into two types, synchronous and asynchronous. First we see parallel transmission. Okay, in parallel transmission, multiple bits are sent simultaneously instead of bit by bit. Okay, it is faster way of communication. It is faster way of communication and it requires multiple wires for the connection between transmitter and receiver. Example is the communication between computer and printer. See the parallel transmission. In parallel transmission, multiple bits are transmitted simultaneously. Instead of bit by bit, we are transmitting the multiple bit at a same time. It is the faster way of communication, but it requires multiple wire for the transmission purpose. Okay, this example is the communication between your computer and printer is the example of your parallel transmission. Next one, it is the serial transmission. Okay, in serial transmission, the data transmitted bit by bit serially. Okay, it requires single wire for the transmission purpose. Okay, it requires mover time for the transmission of data, and it transmit the signal one by one. Okay. Okay, it has start bit and stop bit, that is the MSB and LSB. Okay, this one is a serial transmission. Next we see comparison between the synchronous and asynchronous. We see comparison between the synchronous and asynchronous. So first we see parameter synchronous and asynchronous. First we see meaning, synchronization, speed of transmission, its cost, gap between the data, and example. First we see meaning. In the synchronous, we are transmitting the block of data or frames are transmitted. First consider the example. The communication between the two computers. It is the example of synchronous. So when we are communicating the two computers, at that time you are transmitting the block of data or blocks or frames. Okay. Next one, it is the asynchronous. In asynchronous, we send one byte or character at a time. Consider the example, keyboard and communication between keyboard to monitor. So by using the keyboard, we are transmitting the single character at a time. So this one is an example of your asynchronous. Okay, next one, it is the synchronization. The synchronization which is needed for synchronous and not needed for asynchronous. Next one, it is the speed of transmission. The speed of transmission is fast in synchronous and slow in asynchronous. Okay, speed of transmission is fast in synchronous and slow in asynchronous. Next one, it is the cost. The cost of synchronous is high and cost of asynchronous which is low. Next one, it is the gap between the data. In synchronous it is absent and in asynchronous it is present. Next one, it is the example we have already seen. The communication between two computers and the communication between the keyboard and monitor. It is the example of asynchronous. So what is the meaning of synchronous? It sends the data in the form of blocks or frame. So blocks which is consist of large number of data, frames which is also consist of large number of data. And in asynchronous we send one byte. One byte means 8 bit, which is nothing but your 1 byte. Okay, or character, one character at a time. Okay, next one, it is the synchronization. Synchronization which is needed for the synchronous and not needed for the asynchronous. Next one, it is the speed of transmission. It is fast for synchronous and slow for asynchronous. Next one, it is the cost. The cost of synchronous which is high and low it is for asynchronous. Next one, it is the gap between the data. The gap between the data is absent for synchronous and present for asynchronous. Last one, it is the example. Example of synchronous, which is the communication between two computers, and example of asynchronous are keyboard and monitor communication. Are the is the example of your asynchronous. Okay, so this data transmission, which is divided into two types, serial and parallel, and this serial, which is again divided into two types, synchronous and asynchronous. In serial, we are transmitting the bit by bit data serially. It requires single wire for the transmission. It requires mover time to transmit the data. Okay, at one time we send one bit. Okay, and also it has start bit and stop bit. Start bit, which is, and stop bit, which is also called as a MSB and LSB. Next one, it is the parallel. In parallels, multiple bits are sent simultaneously instead of bit by bit. It is the faster way of communication, and it requires multiple wire to connect the transmitter and receiver. Example of this parallel is communication between computer and printer. And type of serial communications are synchronous and asynchronous. In synchronous, we are transmitting the blocks or frame, and in asynchronous, we are transmitting the one byte or character at a time. Synchronization, which is needed for synchronous, not needed for asynchronous. Transmission speed is fast for synchronous, slow for asynchronous. Cost is high for synchronous, low for asynchronous. An example is communication between two computers. An example of asynchronous is keyboard to monitor communication. So today we seen the electromagnetic spectrum, transmission mode, simplex, duplex, half duplexer. Next one, transmission modes. There are two types of transmission modes, serial, parallel. This serial, which is divided into two, synchronous and asynchronous. So thank you. From next on next lecture we start the next point.